Okay, I've had a few questions about this one that I'd like to give you some guidance on. So what we're trying to do is, if you remember, we did some work on input and output. So if our input is that we have one table, then our output is that we're going to have four people. So here we can see we've got one table and one, two, three, four chairs or people. If we have two tables and we count one, two, three, four, five, six, when we have two tables, our output is six people. And if we had three tables, one, two, three, we'd only be able to put these seats around the outside here. So if we count them, one, two, three, four, five, six, seven, eight. And so we should start to see a pattern here. So I'm looking for a pattern. As this goes up by one, how does this change? How does this change? What do you expect this number to be? And if you're not sure, you can draw yourself four. That's your input, four tables. One, two, three, four, and they're all end to end like that. So that means you can't put any chairs or people in between. You can only put what's there. So if I count those out, I'm confident I'm going to come up with 10. And if you're starting to see the pattern here, what am I adding to get to that? And so then we can take each of these points and we can plot them on our graph. So if I had one table, and the number of tables is down the bottom here, and reminder that on your printed version we've changed this because it was incorrect. It was in the incorrect spot. It's now correct where it is. Because if I have the number of tables and the number of people, one table, four people, that is where my dot goes. And then you look when you have two tables, how many people do you have? When you have three tables, how many seats, how many people do you have? So we'll use that information to go down here to write a rule, an expression that's always true. So if we had 47 tables, how many people would we have? Well, we just need to plug it into the rule. So we need to look at that pattern and think, well, what is the magic number that the number of tables plus some number that will give us the number of people? Remembering, if we have one table, that seats four people. And we can visualize that like this. If we have two tables, that seats six people. There will be a formula that makes that make sense. And then once we have that, then we can use that rule to figure out how many people would sit at 50 tables. So we don't have to draw 50 tables and draw all those circles. The other thing I've had lots of questions about is this one. We've got two angles. We've got an inscribed angle and we've got a central angle. And that central angle comes from this radius. It's a terrible, terrible drawing of the radius. The radius is from the center point and it goes in a straight line to meet the outer edge of the circle. That's a radius. This also is a radius. So we have two radii here. And if we use those, okay, great. And then we choose any other point and we draw lines there, we need to measure them. So we need to measure this angle and we need to measure that angle really, really accurately with our compass. Oh, look, it even says accurately. Look at me. And so then question D is describe the relationship. So I can't say anything further, but you will look at this degrees, this degrees, and you look at them both and compare them. For each circle, you'll have an x and a y, for want of a better word. You'll have two angles, two measurements, and if you're really, really accurate, you can look at them and say, there's some relationship between them that I can see with those angles. So describe the relationship between the inscribed angles means, so I look at what this degrees is, and I look at what this degrees is, and what can I say might be true because I've drawn four circles and four sets of these angles. What can I say is probably going to be true if we have a circle and we do this work with the radii and we draw other lines to a point anywhere? What's going to be true of the inscribed angle in relationship to the central angle?